Boom. Hey, Coffee Compiler Club. Here today to talk about compilers and language runtimes and garbage collection and type checks and anything and everything to do with languages and language theory or language implementation. Everyone asks their own questions and the conversation goes where it goes. You're all being recorded live. I'm done with my spiel. I don't know what other news. The big news is I'm going to JCrete to join Cameron at JCrete for 2 weeks, almost week and a half. So next week CCC may happen and it may not, depending on how jet lagged and time zoned, and the Wi-Fi is decent at the conference center, so it could happen. No promises. You'll see the announcement the weekday before. I'll make an effort, but like I said, things happen. People go out to dinner, you have some beer, time slides by, it's like, oops, done. That's my announcement. What else? I don't have any other set agenda. I don't have any big AA news because I'm splitting time with Cameron's project with Cameron and AA. Let me pull up AA news, but it'll be really quick. History, what did I end up doing? Oh, yes, I had a giant discovery of what the hell I'm doing with, back and forth on how I'm implementing pointers, like pointer primitives 4 times over. Homing in on a better answer, maybe. This is fine. So no, like I said, no big news. Lots of theoretical writing up of what I was forgetting from time to time because my implementation got too complicated to keep straight in my head because I'm bouncing between 2 projects. So that was a lot of what was going on. Somebody else's turn. Nobody else says anything. I'm going to pick on somebody.
What's the pointer thing you're looking at?
The pointer thing? You mean for AA? It was primitives. I said pointers, I meant primitives. It's whether or not I first cut support inline objects or not. So under the current AA theory for primitives, when you call out a primitive, like you've said, A times B, that turns into a field load for a mangled multiply name, which gives me a overloaded set of choices for which function to multiply with, which is int times int or int times float, or you've got a matrix times matrix or whatever the hell you're going to have. Then the choices here are the second load. So the first load is loading me a list of choices, and the second load gets me a function. But the list of choices is a tuple. It's an inline object as a tuple. And so I could have a pointer there to a tuple. So all loads load through a pointer, pull up a struct of some kind, and then you get a field selection out of the struct. And that simplifies one side of things because all loads uniformly load through a pointer to get a struct. The other option is I had inline objects. All my primitives don't require a pointer indirection to go get them done in the typing system. Like all this will filter out in the code gen, but in the typing system, I have to have a pointer indirection. And if I don't have a pointer indirection, then that simplifies some amount of type inferencing on the overload solution because I can directly know that when I got the multiply, I immediately pulled up a tuple of function choices as opposed to a pointer to a tuple, and that was causing me some indirection issue for inferencing. So I went back to, I have directly inline objects, and a load changes me from one object to another, if you will. But if you're inlined, it's a no op, it doesn't do anything. But then I have to know that you're an inlined as a type, and I'm all into type inference. So the type inference says, I can figure out that you're an inlined object or not. Well, that's a big can of worms, because obviously I shouldn't be making, or the compiler or the typing system shouldn't be making the choice to inline your objects or not. So then I need a syntax and the parser to say that I've chosen to inline your objects or not. And it's like, it's a can of worms in both ways. So that's why I went back and forth 3 times on that one. It's not a super deep problem, except it's just like on the first cut, like I don't care, like eventually I would love to have inline objects as a thing. I probably need a syntax to say, you've got a field here and I'm going to infer the type, but you want the object inline. And that's a different syntax. I'm not going to infer that one. Because that's like sharing patterns, and that goes to intention of what you mean on things. So I don't think I can infer that one. So need a syntax bit, and I didn't want to go there, so I had to decide what the hell I'm doing. Or I have a special that says primitives only get to do inline objects, and no one else does. So right now I'm trying to have my primitives be just the same as everything else, so you could write your own primitives directly. You can't do ints and floats to get to the hardware, but you could write anything else and treat it like a primitive and have it behave like a primitive in all use cases, except that it ends up executing user code under the hood. But otherwise, you can do everything, all your operator overloads work and all that kind of stuff. So that's what that was about.
I've been thinking about implementing pointers in my language. I kind of do it right now for extern C, but I intentionally only made it allowed in the standard file, like the standard library file. One thing that was bothering me is.
Wait, so what did you say about pointers? That you only allow in the standard library file?
Yeah, my language mostly supports it, and it's only available in the standard library.
Supports what? You had a voice cut out earlier. Supports what?
Oh, it only supports pointers if it's in the standard library. So user code can't do it.
Oh, user doesn't see a pointer. Yeah, it's like Java. User doesn't see a pointer, but they're there.
Yeah, so
yeah,
I was thinking about allowing the user to declare like this member needs to be a pointer, and it could be optional. But one thing that was bothering me is I'm going to have like a lot of stars, question mark, stars, question mark, star, question mark, depending on like how the user declare things. Okay, well, actually, it's not going to be like that. For the most part, you're only allowed to have one indirection, and then it has to be an object. But I don't like the syntax where you have to put a question mark after the star or before it, whatever the order is. I just seeing both of them kind of bothers me. I think there's should be maybe another symbol, but I don't know how I want to write it that does not look horrifying.
Sorry, I got random late request for an invite from somebody I don't know off the top of my head. And I'm sorting it out, so carry on for a second here while I sort out who I got this from.
Does anyone have any opinions or experience on how often pointers need to be optional?
You mean optional like nullable?
Yeah.
Oh, I do them all the time. I mean, that's a...
Yeah, so I don't know if I should have like a different syntax for pointers that are optional versus pointers that are not. So
that's the classic, question mark after the pointer name, NPE fail, can the compiler help you, or do you have to suffer a crash and burn at runtime for NPE thing?
Yeah.
Let me try.
We don't have NPEs.
I guess for now, I just use a star question mark, and then hopefully it's not going to be as annoying as I imagined.
What's the star question mark?
Like
oh, you want to have an explicit pointer.
Yeah, so if you write like in your members, if you write type star question mark, that means the pointer is optional. And then you just write your member name.
Okay.
Yeah, so I was just trying to figure out if there's
and drop the star.
Lag. Yeah, I was just trying to figure out if there should be a different symbol to say that the pointer is optional.
Where's the Google Docs here?
Yeah, I should pull that up.
Yeah, let me go Google Docs this here, and let me go do share screen, Google Docs, boom, 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 boom. Somewhere, yeah, okay, here you go. Some class is right. and you have a member, and I'm asking why the star. Right. I get the question mark. Yeah, next, brief, and child. Oh, yeah, there we go. Some class tree. Okay, so the land of Java would say no to the star and get you the same effect, except you have to have like a Kotlin add-on or a not nillable add-on to get the question mark. So Leva, why the star?
Because there needs to be a way to say something is a pointer.
As
Otherwise,
opposed to an inline object.
Yeah, otherwise the compiler would just try to inline it.
Okay, so you have inline objects directly, and then you need a star. Sure enough, you need a star. Okay, that makes sense.
Yeah.
I would claim yes, you want to do something there.
So just to be clear, the question mark means the sometime can be null.
Yeah.
I guess you have the other one is
Like right now I have references, but that's only when you return from a if you return a reference, and that is a whole thing on itself.
Java always passes them by pointers, yes?
yes. So the star is implicit in Java, but it's always pointers.
In my language, the compiler chooses if it's by value or by pointer. You don't have to say anything.
But that changes the sharing patterns.
The
So-
compiler tries to figure out what's the best way, but for the most part, if you want something to be immutable, you have to say so, and then that will also change the pattern. So it'll just
I see.
try to make it as easy as possible for you.
So like if it's an immutable thing and it was small, you're going to inline it. And if it's immutable and big, I assume the compiler decides to share because it's big.
Yeah.
And if it's mutable, it's just shared because otherwise you broke your sharing pattern. I mean, it's just a pointer because you broke your sharing pattern.
Yeah, but also there's like in my language, there's no you can't take a pointer after if it's passed in. There's like the whole ownership thing. So,
I can't store a pointer that's passed into an object.
yeah, because there's
lifetime.
like a lot of ownership rules. The rules that I have to implement that everyone wants to see.
Yeah, exactly. This is yes, ownership. Fine.
See, I was thinking I can use a reference, but that might just be more confusing. Like, because normally in C++, you don't have references in well, you don't have references that change in members, like in structs, but I want them to change. So reference seems to be the wrong symbol to use. And I guess I could just always use pointer star. I mean, yeah, pointer question mark, but I don't know, for whatever reason, it was bothering me. Like I thought maybe I should discourage it somehow, or like, I don't know, but it was just bothering me and I don't know why. It feels so quiet today.
No, I'm yes. We got two people who I haven't seen in a long time. I don't remember who they are. I'm going to make them speak up so we get to hear what's going on. I also invited some new folks to last week that maybe first or second week for these folks to show up, and that's the reason I don't know who they are. So Nixon, can you say like 10 seconds of who you are and why you're here? Because I don't remember who you are.
Yeah, so I'm asked ages ago on Twitter, and just my timetable hasn't lined up with being a student, but I do Rust stuff mainly on the documentation system, which is you're interacting with the front end of the compiler, but sort of saw it on Twitter and interested to learn. And yeah, thanks for inviting me, I guess.
Okay, but what's your actual name?
Nixon.
It is Nixon. Okay.
Yeah.
Send me your email in private chat so I can line you up with who I'm sending invites to, because I'm confused. It's fine. And then Andy, where is Andy? Andy Glock was on for 30 seconds. There he is. He's on now. Andy, say something about yourself. 10 seconds, 20 seconds. Find your sound. You're not muted. Can you hear me? Connecting to audio now. Yeah. Okay. Yes. Zoom claims you don't have audio yet. Fine. So, okay. So Nixon, you're doing stuff with the Rust documentation. Is that what I heard?
Yeah, so there's the documentation generator, which I think it's like Java doc, where it takes in your source code, spits out an HTML file, but I'm working on that mainly to add sort of machine readable output to it, so that if you want to like say, what does the API for this module do, you can do that in like a machine readable way without having to interact with the compiler directly, because it's quite a pain to set up a Rust compiler session. So that's the main goal of that.
Okay, so are you hacking on the parser for the guy or the IR? Where are you coming in at the compiler here?
So there's an IR called here, which is, it's basically an AST with some desugaring and some of the types, it's done name resolution. So we take that and then do a series of transformations to remove bits that are irrelevant, like you don't need to look at anything in function bodies, but just you also take that and produce another IR, which we can serialize to JSON.
Okay. All right, cool. Yeah, a bunch of people are, by the way, are dropping and joining on the audio fail. It's like, yeah, not alone here. And how about now, Andy? Can you hear me now? Can you hear me now? No, connecting to audio. You're gonna fail again. Damn it. Wow.
There was a check mark, so you might be able to hear us now.
Yeah, for a second. Oh, claim so. All right, Andy, 10 seconds of what you're doing while you're here.
Okay, can everybody hear me? Yes.
Yes.
Okay, great.
Yes.
There we go. No idea what happened. Okay. Yes. So I am the team lead for the C# native AOT compiler at Microsoft. Why I'm joining? I don't know what the current topic is. I am happy to talk about anything. I don't know. I was just kind of curious what other people were working on, what other people were thinking about. The thing that I'm thinking about a lot recently is the fact that you can't really cross-compile C code. Like, honestly, that kind of sucks. It feels like in 2023 we should have a solution for this, and I would like for that to be the case. It seems like the industry, like a bunch of people probably need to get together to make it happen. But it seems unfortunate regardless.
So to answer your question about what we do or who's doing what here, about half the people here are writing their own language because they gave up on C or Java. And half the people here are working in the guts of somebody else's language, implementing, C or implementing Java. And it kind of bounces around from week to week and month to month, who's on, who's not. I have some people been regulars for many months, have been missing for the past 2 that are doing their own language thing. I myself am writing my own language. I piled on to Cameron's language also, so I'm now splitting time between 2 language implementations.
Cool.
As for the C question, most of us kind of gave up on the undefined behaviors out of C. Having written large, complicated C++ programs for many years, I mean, I fully understand what's going on there. But just simply because the spec of the language is unspecified, and you can't change the spec without getting screaming madness from the hordes, right? So I think your goal of saying I can cross-compile C means I don't have any undefined behaviors out of C, which really means everyone agrees what the semantics are, and that's not the case.
Yeah, so that's kind of true. I guess my difficulty is actually in ABI compatibility. So yes, it's true that I can't compile. Well, it's true that C is inherently going to be like, compiler determined, right?
Yeah.
But at the same time, the thing that really gets me is that I can't link binaries
Yeah.
across platforms. Like,
Well-
there's not a whole lot of options other than OpenSSL. And it's like, I would love to be able to link against OpenSSL on a Mac or on a Windows machine and just have it work. But, you know, how are you supposed to compile against glibc on a Windows machine is something that just really bugs me, because this is something that native AOT cares about a lot. It's like, we would like to be able to compile C# to native code for all platforms from any platform, and it's just stuck, right?
Can you delay the AOT definition till link time on the platform and still consider like everything's done except the link at the last step?
That's exactly what we do, which is fine, except that it's not quite good enough, right? Like it is still the case that somebody has to go get, you know, a Linux machine with the right glibc, and that means an old one, because of course you want your thing to work on old computers, like old distributions. Let's say Amazon Linux 2, for example. And that's just terrible.
Well, you know, that's why you get paid money, right?
Yeah.
Life
also-
sucks and you take your money. Fine.
The other thing I was just going to mention was I was also a member of the C# compiler and C# language design for about 8 years. So if people want to talk about languages as well, that sounds cool.
We often talk about languages. I don't know how much love you'll get out of C#. Maybe people run here, go back and forth between who's going to hate. Well, I guess C# lands pretty squarely in the decent category.
It's fine.
You know, we can pick on Scala pretty easily. And you know, like C, C++ are too much like a straw man. It's like kicking a man who's down. It's like, what's the point?
C# is solidly like an evolution of how it was built in 2000. You got to just accept the fact there are certain common ideas about how to build languages at that time, and Java was the king. And so, you know, you evolve from there.
There you go. Yeah, fair enough. I don't have any other C# things to say. I don't think anyone else wants to pile in on C#. And you're welcome to like throw out a topic that you wanted to ask somebody about, just to see if somebody has a, you know, comment to say or add.
So, Andy, how well do you compile C# ahead of time without the JIT? But is there a performance difference?
So it turns out that we've done a bunch of experiments. So we have native AOT has gone through like 4 or 5 different iterations of this. And we've built on a variety of different technologies over the years. We tried to build something on the kind of the Windows C++ backend, which is called Nutsy. And that's the optimizer for them. And we've gotten decent performance out of that at the cost of pretty long compile times. We had an LLVM stint for a bit. What we finally settled on was actually running the regular core CLR JIT in its most aggressive mode as the code backend. And it's pretty much equivalent in throughput. The benefits are primarily around, you know, you get a small single binary that's portable across, like you can target an arbitrary device. And as long as you build it on something similar, as I mentioned, you can target that and get a small binary with really fast startup. So you remove JIT from your inner loop, you remove type loading from your inner loop. And you get slightly lower memory usage as well, because you don't have to deal with the overhead of doing JITting. And then we link in the same GC. So it's the exact same GC as in core CLR. Part of the benefit here is sharing components. Like, you know, doesn't matter how big Microsoft is, you only get a certain amount of budget to do things, and sharing as many things as possible makes everything good. So the results are like, there are a few places where core CLR is getting much better and doing a lot more things that it didn't previously, including like what I think Cliff used to call heroic optimizations.
Yeah, still do.
Still do?
Still do.
and those kinds of things help a lot. Like you do end up with these benchmarks where the JIT and the runtime basically figure out exactly what the input is and just start optimizing exactly for the same request that you're going to throw out at 1,000,000 times a second. It's hard to beat that. It's actually almost impossible to beat that. So we lose in those situations, but overall we're getting much better.
Yeah, I had a burning question. So in on Linux, I was using I think 3.5, and everything was fine. I tried it last year or 2 years ago. It takes 2 seconds to compile "Hello World." Why is that?
For native AOT,
I'm not sure what I did, but I just remember the C# compiler taking 2 seconds.
Hold
the
cache
C#
or-
compiler should take a fraction of a second. The chances are that like something got screwed up. The most likely situation that I can imagine is that somehow the install got screwed up, and it was doing a ton of jitting. That would be the answer. Usually, so we have a long history of ahead of time compilation. The current is native AOT, which is only native compilation. Like there is no JIT. We removed it entirely. But we also do partial ahead of time compilation. If partial ahead of time compilation somehow got screwed up and you didn't end up with, you know, let's say most of the standard library being ahead of time compiled, then you're going to JIT that all at startup. And so it's going to be really slow the first time. Ideally, it will then amortize because we have a compiler server that sits in the background. So as long as you issue another request right afterwards, it's going to be fast. But like that sounds like something got screwed up.
I used several distros. I don't know how to specify ahead of time, but I was using VS Code, several distros, and then I compiled Hello World, and it happened every time I compiled Hello World.
Yeah.
So I had to stop using C#.
So I'm thinking that the problem was that particular binary that you got was like somehow screwed up on our side. Every once in a while, we have some sort of packaging mishap, and like something goes wrong, right? And then the binaries get like messed up.
Okay, I'm gonna try it later today, but because I used to really like C# and I just couldn't stand the compile times.
Yeah, it's that or it's something else interfering, which obviously I can like try and help, but yeah, it shouldn't be. It should be like a fraction of a second.
I asked online
100 milliseconds or something.
I asked online and no one actually gave me an answer of how fast it should be, which is really annoying. Like if people can't tell you if something is less than a second or more, but yeah, I think I had one other Arch user have that problem too, but that's Linux.
Yeah, it's hard to tell. Like I'm not sure how much anybody really knows what things should be. They just kind of do what they do.
Well, you get your production install versus whatever, and then the installation screwed up, and then yeah, that one's not really a compiler bug. That's just how to do production install. And
yeah, I can try running it. So like my daily driver is Ubuntu 2204, so or whatever the latest one is. So I'll go try compiling Hello World for you.
do it cold and then do it back to back.
Yep.
Yeah. I was also thinking about ABI this week, and that's a tough problem that you guys are trying to solve.
Oh yeah, yes. Well, also for the giant old history of x86 ABIs with the 200 flavors of 32 and 64 and compressed pointers, and I don't know what all the different variations are, and whether or not you pass arguments of this register or you assume SSE or something. I don't know. I know there was a 27 when back in the day. I bailed out of that for a while.
It seems to me that every foreign function you call and every system call has to have some kind of OS specific wrapper around it. And that's like a lot of functions, so it doesn't sound pleasant.
Well, yeah. I mean, you have to agree on what your ABI is and how you're passing pointers around and the like.
Well, you can't.
Varieties.
Well, the wrapper would just like internally that's like not hard, but you got to do that for every. I was actually just mostly thinking about how annoying it would be for the system calls. I just have a very thin wrapper around the system calls, but if I had to rewrite functions for every OS, it would probably just annoy me.
All right, Andy, you got to beat 2.5 seconds there.
So I also remember exactly what the problem is. So there's a restore step that happens, like basically a NuGet restore, and that's automatic. So you're gonna pay the cost for checking to see whether everything's up to date, which for NuGet restore tends to be fairly expensive. And so there's also a -- no restore flag, which now the good news is
I'm sorry, what's
it
the
shouldn't scale. Like it should cost roughly the same, even if you have a million lines of code.
what's the restore flag? Sorry, I misunderstood that one. Didn't hear.
So there's by default .NET build. When you say .NET build, it'll run a restore, which is the NuGet like package dependency restore. If you want to stop that, then there's a flag -- no restore that turns it off. So it just assumes everything's up to date.
So
But-
you mean a GitHub get or whatever? Not
Yeah,
GitHub.
yeah. It hits NuGet, which is it's effectively our package manager. So it'll hit NuGet.org to figure out whether or not everything's fine.
What do you do if you got no internet?
The package manager is part of the build system or the compiler.
It is. It's part of the build system. The compiler has no idea. There are so many layers here.
So, okay, so right. So now question is, what do you do with no internet? And then I have the bad question after this.
Yeah, the answer is like it's bad. There's a lot of stuff that's kind of dependent. So the standard library is kind of there no matter what. But even if you have no package dependencies, it checks to see if you have any package dependencies.
And if I have no internet, what's it do?
It should, if you have no package dependencies, it should simply say this is fine.
No internet.
Yeah, it should say this is fine, and still build. If you have any package dependencies, it will fail, and you have to pass -- no restore to tell it to shut up.
Just fail. Okay, because the other thing happens is I fly on a plane, even in a couple of days to go to Europe.
Yep.
And I have Wi-Fi on the plane, and it's 2 bytes a second Wi-Fi or something stupid. So every time I do a build, if it goes touch Maven and tries to download a few megabytes of, hey, it's all up to date, it'll take hours fucking over the airplane Wi-Fi.
Yep.
So like, I cannot have anybody touch the internet when I'm trying to do work on a plane.
It's incredibly frustrating. I've run into this as well.
Okay,
So yeah, you have to pass -- no restore.
Okay, fine.
It's like, it's a trade-off. I don't know. The trade-off is
Fine.
you tell new users, hey, you have to go learn about how the package management works in order to do the simplest thing, or you turn off the package management and make it a separate tool.
Right. And then if you turned it off all the time, like, why was it turned on in the first place? Fine. There's one time I'll touch.
I lost this fight. Let's say that.
Okay, fine. So are you able to rerun your test with the no restore here?
Yeah, that's what I'm doing right now. And I'm trying to also open this up so I can see exactly how much time the compiler in particular took, not the build system, but the compiler.
Oh, okay. Yeah, it is a question. If I can get into the mode where I'm just invoking the compiler, it's convenient for the development cycle. I'm not
exactly
everything else on the planet here running around. Like, I still use make for that very reason. I can turn all that other shit off.
Okay.
And I have my 1-button Emacs insto, go to next error, just compile and go.
Here's the no restore build and the actual time executing.
That's more reasonable.
It's more
actual time executing CSC.
Yeah,
is 52 milliseconds.
Yeah, that's coming off of your compile server, right?
Yeah.
Yes, I'm about to say that's the reasonable number for Hello World, not the 1 seconds or 1.1 or whatever.
52 milliseconds is the answer. The real answer is that the MS build thing, our build system, is not fast. It just isn't. I would love for it to be fast, but boy, is that a mountain of technical debt.
It's at least 2 seconds too slow.
Yes, yes, out of 2.
I-
Hey, you're
Yes.
like 99% in the build system here.
Yeah. Oh, by far. Like at
Oh,
one point, we
it's a couple
took
more
a
decimals.
massive, like actually compiling the compiler, which materially starts to like, you actually get to see the compiler work for
Right.
that one.
Right.
And I think it takes like 20 seconds, something like that, for a couple million lines of code. This is the compiler and all the IDE stuff. And if you go into the build system and you hack it up so that the compiler just fetches the asset from disk, fully cached, right?
Mhm.
The actual time only gets cut by 1/3.
From
Yeah.
The actual end-to-end compilation time is only cut by 1/3. The overhead of running the build system is 2/3 of the total time.
That's rough.
Yeah.
I actually got so sick of the build system that I took my ASP.NET program and just made a static site instead. And I use Python, which I only sort of know, to generate the static HTML files. My compiler compiles many millions of code per second. So it feels weird whenever I have to wait like more than a second for anything.
The answer is, of course, MS Build is a pile of, you know, 500,000 lines of XML that is a language.
Eesh.
And it is at the way that it's working is interpreting 500,000 lines of XML every time you run the build. So that's why it's so slow.
And I make a recommendation, but I don't work for Microsoft, so never mind.
I
You
don't
take that
understand
person
how.
who decided on XML and you take them out back and shoot them.
Yeah, it's way far too long, 2001 at least. So
Oh my God.
Yeah.
Wait, that's for the .NET code is based off of code back then, because I thought .NET was relatively new.
no, so C#
Oh.
it was built in 2001.
Yeah, let's say it came out shortly
Yeah, but-
after Java came out.
I thought .NET was a completely different, like a complete rewrite.
No, it was mostly a port. Well, there are pieces that were rewritten for cross-platform compatibility, and that was 2014, I want to say. We had actually already done it for Silverlight. So Silverlight came out in like 2010 or something, and that was .NET inside the browser. And that was cross-platform, so it had pieces for Linux and Mac. And we decided to build Core CLR, which was like the cross-platform version of .NET that was not the Windows desktop one. And that's the modern thing that runs all the places. And that's mostly the same code with a few pieces that were like, didn't make sense / mistakes. Like we figured out we made a bunch of mistakes over the years. Like for example, there was this thing, code access security, which is like an attempt to make this kind of secure sandbox. And boy, was that a bad idea. So we just ripped out all that code and said, this is not working. Your sandbox is at minimum the process level. Like go make a new process if you really want to do this.
Yeah.
But it's basically the same code underneath.
I'm surprised that people didn't feel it was such a problem to actually do a rewrite.
There were a few cross-platform pieces that were problematic, but those were with like the PAL layer. You know, when you think of a runtime, a language runtime, the vast majority of the code has absolutely nothing to do with it. It's stuff like loading types, compiling stuff. If it was good the first time, it's probably still good. And if it was fast the first time, it's probably still pretty darn fast. They're the problems, but like if you start rewriting, you're going to just have a whole bunch of other problems too.
Yeah. Yeah, I get that.
It's like how much do you care about compatibility is like the big one, I'd say. If you care about compatibility a lot, then your costs are going to just be insane to try and get bug for bug compatibility, because we rewrote the C# compiler from scratch in C#. That was expensive. Like that was, I want to say that was something like 60 dev years of work, some insane amount. Like unless we had Anders, or somebody else like who had clout plugging for that project, that would not have happened.
I see. Yeah. This isn't exactly related, but have you seen that Windows terminal video of a guy doing it like much faster? Like it was something like 100 times faster.
Doing what?
A guy showed a way to render something, and it was like something like 100 or 1,000 times faster than doing a cat on Windows terminal.
Oh, cat on the terminal. Yeah.
I don't really, sorry, I haven't seen the,
Okay.
I don't get
it
into
was-
those details most of the time.
No, it made rounds across a lot of the programming channels like 2 years ago, I think.
Yeah.
It was a great
Is
video.
it Windows Command or any number of other shells? There's like a bajillion. I had
So
Git Bash going here.
the story was a guy posted on the GitHub issue saying that this is too slow. If you do some basic caching, it will be significantly faster. And one of the devs said it was a thesis project or a research project. And then the guy just like whipped out an example in like a weekend, like 2 days kind of thing. And then demoed it, and like everyone started like retweeting it and making thesis jokes and all that. I'll
Find a
send
link if you can. If there's
yeah,
some entertaining
I'll
value
look
there.
it up.
Find a link. We'll put it in the docs. It's all good.
I'm
So
really
what's
surprised
your-
no one here seen it.
What's your current exciting project du jour, Andy, on .NET C# things?
Oh, I mean, I still think native AOT is like a big project, right? So things are not strictly compatible out of the box. There's a big problem when you come with native AOT, which is we have 20 years of history of C# being able to do things that are not particularly AOT compilation friendly. I'm thinking mostly about, things that require JITting. So being able to load new DLLs written in .NET IL, obviously that's going to require a JIT in order for that to work.
How do you deal with reflection?
And reflection. Reflection is another problem. Reflection is surprisingly interesting. So you might think it's a big problem, but it's a problem, but not for the reasons you think. Implementing reflection in an AOT compiler is actually no problem. Like you just keep the metadata around in some form, and then you return the same information that you would before. The problem is, which metadata do you keep around?
Yeah.
That's the main problem, because if you keep all of it, then you're screwed, because you're going to end up with everything.
By metadata, you mean a type information?
Yeah.
Yes.
Yeah.
Type information, but also code, right? Because you can use reflection to execute the code. You can do things like call methods by reflection. Just do method info.invoke.
Right.
Okay,
The same thing
that's
with
the
Java
minimal. The
does.
class name, the method name, that's a minimal kind of reflection, but the more
All the
heavy
code.
stuff.
So you keep the AOT head code on those reflective calls as well. Then you can't.
Right.
You
So
can't
you
flush-
just you basically treat this like a tree shaking problem.
Yeah, that's a tree shaking. Yeah, right.
Yeah, and the main problem is that if you don't do a little bit of work on reflection, then you shake away too much. And when somebody goes to do reflection, it's game over because you shook away the thing that they needed.
They call. Well, you just give them some sort of exceptional crash. I mean, an exception.
Yeah, that, or sometimes the reflection code actually has the ability to return like the method you're looking for is missing. So it would just return back. Yeah. Okay. But even that is kind of bad, right? Because like in some sense, even a crash would maybe be better. Now you're just behaving differently. You're going down a different code path than you were before.
Right. Yeah.
So what can we do? Sometimes we can't do anything. So here's a great example. I do console.readline and take the string and then say type.getType string and then method.invoke.
Right. I get it.
Okay, game over, right? Like the only answer there is keep absolutely everything that I see.
Right.
which
Right.
congrats, now you have a 500 megabyte binary. Like that's just not, that's not feasible in any way. So the alternative is try to build a type system feature on top to annotate reflection such that people can say, I need this, I need this, and I need this, and then produce a warning or an error every time you see something that could theoretically require more information that's not provided. So what we did was we took the reflection API, and it has things like get methods, get properties, get whatever. And we built an annotation called dynamically accessed members, and then an enum that's like public methods, public properties, public fields. And if you go and do a reflection call, if you call get methods somewhere on a system.type, which is our reflection view of a type, the compiler is going to say, hey, did you annotate this instance of system.type, this variable, with dynamically accessed members.public methods? If not, I'm going to warn. And then you just make this, it's effectively a generic constraint.
Yeah,
And then you propagate it all the way up the type system.
Yeah, I'm getting it. That's pretty.
And so now everybody on the minus, you're forced to go annotate your stuff. But on the plus side, if you do, it should work.
Yeah. I like Java's solution. Did it all.
That's the alternative, right? And the only problem is all of the problems with jitting, which are fine. Like, honestly, it's a, you know, it's not like Java or Core CLR are not successful. They're wildly successful. It's just a question of, do you want to be able to do something different? And there are some domains where you have to, like, what if JIT isn't just simply not allowed on your platform? Okay, I guess.
Do you have platforms that's true?
iOS.
Oh geez. Do they not? They still, I know they did back in the day, they still have that issue. Like, okay, fine. I mean, I would
I
just.
remember someone
say-
said something about writing to file and then loading the process.
Right, I would just say, okay, you're stupid, so I'll work around you, but it's going to be slow, but I'll just work around it.
There's also, I would say it's becoming more common. Certain platforms in the deep parts of clouds are restricting JIT because they are basically making it illegal to do read execute pages.
Yeah,
I
this is
think,
like a one.
I think I
well,
remember Max saying that on both Mac and iOS, you can't execute signed binaries unless they're signed now. So I don't think that's write to file and loaded will work anymore.
Well, you could sign it and, I mean, write it and sign it and load it, and whatever. As long as you have a local signing thing going on, you can just.
You'd have to have a local key, which you can. There's an ad hoc key.
Yeah.
That it still won't work great. Like, it'll kind of work. iOS, you can't do that because you can't even necessarily you can't necessarily write it to a file. Like, their permissions model doesn't allow that.
Right,
You certainly
if I-
can't deal open of
if I-
an arbitrary file.
I can't do a /temp and write to
No,
a file.
You have some restrictions. I don't remember on all of them.
Yeah, fine.
but-
I don't either. I mean, I don't know. I'm just.
Yeah.
Working around. Like there is interesting performance things going on here. Now, in the case of read execute, I mean, I did, this is like mostly jitting is write once, flip the switch, now it's execute.
Right. Yes. So we do that. And so that's not the strict provision that I'm talking about. Like that,
Okay.
most people now have worked around the write execute restriction.
Okay. And then in the land of Hotspot for doing a bunch of internal fun things, he does do self-modifying code.
Yeah.
Inline caches, which is a read, modify, write on your execute pages. And that's, yeah. Okay.
Yeah. So that's just like in certain areas of like cloud providers, they just don't even allow that.
Okay.
They don't allow any jitting actually. It's just a broad, you cannot jit.
Huh. Fine. Interesting. So I'm not familiar with this set, which is fine.
I mean, it's kind of niche, but at the same time, it's also like the restrictions are what they are, and you kind of decide whether or not you're willing to play there. And
Right,
that's-
exactly. Yeah, right.
And for a hobbyist, I would say never, right? Don't
Yeah.
make your life harder for no reason. But business is a business.
So,
you
but,
either
well, the
put
question
up.
is, wait, what's the profit model that says it's more profitable for us to deny jitting, which means, for instance, no JVM. You
Yep.
shut out hotspot. So you have to write your code ahead of time. We can take your binary, it's ahead of time known to us, and we can do something with it that's more efficient, and we'll give you a cheaper solution that has to be reasonably cheaper. Or else I wouldn't bother. Why would I bother to sign up for such a page, such a cloud
Yep.
provider?
Oh, in this case, it would likely not be on the consumer side. This is the hosting side. So if you are, let's say, deep in Amazon or deep in Azure, you may have a restriction that you are not allowed to JIT in certain areas because of a security concern.
Yeah, okay. Oh, inside I don't know then.
Yeah, the hosting side, like the
Host
actual,
itself
like
is doing something.
you're
right.
hosting the cloud compute pool for whatever.
Yeah, okay, fine. Yeah, then I don't know what they're doing. Yeah, fine. I have certainly used Amazon and JVMs on Amazon.
Oh yeah, that's fine. Like
Yeah.
you're a customer. They
They're a
want to
customer,
give you
yeah.
whatever you want, right?
Right,
It's
yeah,
it's
right.
more about like, okay, in the cloud infrastructure itself, do we want to
Amazon, by the way,
allow?
kind of lies about whatever you want on that one, because I tell them I'm running a big data machine learning, and I'm going to eat all your cores and all your memory bandwidth. I want solo hard memory machines, no neighbors, and I want them co-located near each other in the racks, because they're going to talk like hell between each other.
Mhm.
And they would say sure, and then 99 machines out of 100 would be pretty good, and one machine would be totally slammed by somebody's MySQL neighbor and get his entire bandwidth and disk IO, whatever, all just munched all to hell. And so he'd be, the last man out by a factor of 10 or something stupid. And so we ended up putting bandwidth measuring as a background 1% task to measure whether or not we're getting full bandwidth, and routinely saw failing guys get like all their bandwidth eaten away. And so we had to bitch and moan at Amazon. And after bitching and moaning, because we paid extra for this, they wouldn't do it. But the first cut was, you paid money, but you did not get it. And then if you bitched and said, look, I have evidence that you're lying, they would say, oh, okay, here you go. Suck.
Yeah.
Fine.
Yeah,
I was
and so-
wondering at Microsoft. Actually, go ahead.
Oh, I was just gonna say, this is like, this is one example, but you can think of a bunch of others. Like there's iOS, but there's also like the iWatch, and then there's really low power constrained devices
Yeah.
where you're
Oh,
gonna
yeah.
spend, you don't really want to spend the time JITting, right? Like
Yeah.
the JIT is battery life. The
Yeah.
JIT is like wasted work, because you're just doing it for every one of these devices.
Well, it's not wasted in the sense that I think it's not the waste. The waste is it has to pay for itself in battery consumption. It has to make a better running, faster running code versus the cost of the JIT is part of battery.
Right. And oftentimes these are really short-lived processes. So,
Oh, that would
the JIT time is probably not going to make itself up.
Yeah. What devices are you talking about then? Because I'm thinking of like, well, I've done embedded recently even, and they were not.
So this is a different category. They're like short-lived processes as well for, let's say, AWS Lambda. People put these things and they execute, and you don't want,
right.
your whole thing's going to be 15 milliseconds.
Yeah,
You don't
right.
want the first 5 to be JIT.
Yeah, I get it. Yeah, that one needs caching badly. It needs a outside the process level JIT caching.
You
Or
can do that.
AOC.
It's hard. Like the bugs just suck. Like honestly, that's the problem. The bugs suck so bad.
All right, fine. I certainly fought my share of bugs with stale code and Hotspot back in the day. They came around, that's for sure.
I was wondering if Microsoft was trying to do something with memory safe languages, because like Mojo is
Rust.
memory safe apparently. So it seems like a fad now. So I was just wondering if they were trying to attempt to do something with it.
So C# is, let's call it,
Hey,
so
bio-
like, let me define what memory safe means to me, which I think is the categorical definition of memory safe for most people, especially if they take it from Rust. Memory safe means that if you write the code in the safe subsection of your language, then you will not see memory corruption, which is defined as, reading unassigned memory, going outside the bounds of your allocations, and what else?
Are you gonna leak or you're not gonna leak?
I think leaking is not within, certainly leaking is outside the definition. Leaking is okay. Like you can leak
Okay.
memory as
That
long
was-
as
that-
you are not seeing, basically seeing memory violations.
Right.
See,
Supposed to be
I don't.
Java
I
memory
absolutely.
safety, but not Rust memory safety.
Yeah, I absolutely don't agree that you should be leaking in something that's safe. And
Rust
JavaScript,
leaks.
C#, yeah, but JavaScript, C# and
Does
Java
the
are all
safe
memory safe.
does the safe section of Rust leak?
Yes.
You're not required to clean up everything.
No, Rust has affine types, which means that it's kind of, there are a few places where if you do the wrong thing in safe code, you will leak a pointer. You will
Oh.
forget to drop,
Yeah,
quote
right.
unquote, drop
Yeah,
it.
forget to drop. Right. I thought they had that. That was part of their whole schmick. Was it? They stopped the leak too.
Linear types will do that. And to be clear, I'm talking about like, I'm nitpicking, right? Like this is a
Yeah.
very specific corner. The vast majority of code will never see this.
Okay, so linear types are not leaking. Affine types could leak.
Yes. And linear types are, I believe somebody's working on a proposal for that. So like you will eventually be able to get to that space.
So,
The main distinction would be that affine type is at most once. It doesn't have to be used,
Correct.
but
It doesn't have to be
used.
exactly once.
Yeah.
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 Okay. And that the at most lets you drop something occasionally.
That's my understanding, that they are implicitly always called to drop, but that at most once some leak it somewhere.
And sometimes you can basically forget to drop. That's the situation.
Right. So C# lands in this category of memory safe, no read uninitialized, no read outside bounds, no double free, no extra whatever, and maybe a leak.
And I'll put an asterisk on this. So when I said, if you say within the safe bounds of the
Yeah.
language,
Right.
and I think for this to be perfectly meaningful, you have to very clearly define what are the safe parts of your language and what are the unsafe parts of your language. I think C# is about 90%. The problem is there are various library calls which are not clearly part of the unsafe part, but they are. In particular, the interop space, for example, the Marshall things, those are all technically unsafe. Anything in the memory Marshall namespace is unsafe, but you don't see it. That is, there is no annotation that it's unsafe. This is something we're thinking about addressing.
Okay.
I thought all of that won't leak any memory, and you might just have to wait until a garbage collection if you don't use the using keyword.
That is not specifically about memory or leaking memory. The memory Marshal can do things that is explicitly unsafe, like reading uninitialized memory and segfaulting. Like if you use the memory Marshal APIs incorrectly, then you will segfault. Like it's pointer math underneath.
Oh, I see. So this isn't like stuff that happens behind the scene. This is a user using it incorrectly.
Yeah, if you call the memory Marshal APIs, then you can cause a segfault without any clear indication that you are entering into an unsafe portion of the code.
Yeah,
and so that is where I'll put the asterisk of like, this is probably not great. It is true that
these
are fairly niche APIs, but like we should mark them in some way to say that they're unsafe.
The nice thing is I never actually needed the Marshall APIs or anything that's unsafe. So C# has done a pretty good job.
Yeah. I'd say that, like, same with Java, right? I suspect that there are the places that interrupt with JNI or whatever, where you can probably end up with the same problems, but
I'm
Where
still
do you
never gonna go
code,
back. because of
JNI
builds.
code is clearly flagged as unsafe because you're calling.
There you
native,
go.
And native does whatever the hell it does.
I
They
still
made
like
it-
that handle thing that you mentioned.
Yeah, they made it difficult, but not impossible. Because originally it was JNI just handed the raw pointers off to the native who did what they did. And people lied through their teeth about what was broken and got blamed the JVM, and we could turn around and proved it to them that they were screwing up. And so we just kept changing the API for JNI. So now JNI calls have a lot of overhead. In exchange, you have to blatantly be cheating. Like we hand you a handle, not a pointer. If you peek through the handle and screw around inside of there and then hang on to that thing, you did. And then you're broken. And everyone knows, don't peek through the handle.
Yeah, that's even better. Like, honestly, that's better. So ours are straight up. So C# does have unsafe blocks. Explicitly, like you type unsafe and then open curly, and then
Right.
you have raw pointers in there. Like there's a pointer type that's not the reference type. You can use a raw pointer in there. And yeah, you can go wild, take pointers to stack memory, walk up 4 bytes, fine. All of that's fine.
Yeah.
And that I think is fine because it's demarcated. It's the APIs that basically do that underneath and are not demarcated that I think are a problem.
Does the team ever talk about Zig or Odin or any of those languages?
I've talked
Or
about
even
Zig a
D.
few times.
Mm.
The most interesting piece was their cross compilation thing.
Yeah, I thought they had a really nice story there, but otherwise on Zig, I'm like, fine.
It didn't seem, I don't know.
See,
Their
I
cross
was
compilation, their interop seems cool, but like I'm a very type system person, and they seem to like eschew what I consider to be like proper type system things for like this
So-
const like inlining kind of thing, and I'm just like, I don't really want to. That I've been too close to that stuff for too long. I don't really want to go back.
So I had 2 thoughts of the cross-platform thing. So I figured out a way to do it in my own compiler, but it seemed like the Mac or Apple says that you're not allowed to do this for iOS and Mac. So I kind of like someone told me that Go does it, but it seems like the Apple terms of service says you're not allowed to compile for Mac if it's not on a Mac. So I haven't done it, and also I kind of don't want to do it because Zig is doing it. It's their thing, and I don't. It would seem like I'm trying to copy them. So I'm hesitant on implementing something like that in my own
People
compiler.
copy each other all the time. Don't let that stop.
Yeah,
What's wrong with copying great ideas?
yeah. That I'm totally up for. Don't like, yeah, that's great. Don't-
You mentioned you're a type system person, but what is your favorite style of type system?
You
I mean,
functional.
like functional, linear, structural, some flavor.
Yeah.
in
So
between?
you mean if I wrote my own language, what kind of
Uh-huh.
type
Okay,
system would I
yeah.
have?
Yeah.
I go back and forth on refinement types. So like basically I'm like back and forth on dependent types and figuring out how much of them I want to bring in without making the whole thing
So
problematic, to say the
why do you
least.
why do you think dependent types is a must-have feature? Why do you think they will solve? What will they solve?
I don't think that they're a must-have feature, but I think refinement types or something similar provide a capability which is great, which is effectively. So when I think about type systems and the things that I love about type systems, it's defining invariants around various parts of the code. Like the way I think about things and make things work as a programmer is I always attempt to define the invariants that I want to preserve and then code such that I can see in the code that it structurally preserves said invariants. And then I have this argument that I can make of why this code is correct, if you believe the invariants are correct. And then people can poke holes and I can basically decide whether the code is correct or not. Refinement types allow you to express almost arbitrary invariants at basically any point you want in the code, which gives me as the programmer and designer a huge amount of flexibility.
But
Got it.
refinement types,
Got a good link to a starter for refinement types.
Yeah.
that would be cool.
Maybe the liquid Haskell paper.
Throw it in the links. I mean, I've heard and I've screwed and stared at refinement types briefly only. I've not gone a head down other than somebody said, hey, they become undecidable fast for typing. And I'm like, no, I don't want to go there.
Oh yeah, that's totally correct. Like there are significant downsides. And as always, I think that the delineation between research and implementation is like finding how to constrain these things such that the actual implementation is nice while providing a certain amount of power.
Yeah.
So what do you think about compile time static array bound checking?
Your version is, never mind. Fine.
Go ahead. Yeah.
No, I was just wondering if you think you can do that, or
C# do
what the problems.
bounds checking. You mentioned that you can't get out of bounds, right? So
yeah, it does runtime bounds.
That's runtime.
Yeah.
Okay, I'm moving your link into the Google Docs because we use the. Do you have the Google Docs up? Sorry, for Andy's sake.
Yeah.
Jeez, Google.
So there are a bunch of papers, but I really like linking to F* for people who haven't played around with refinement types much, because it has like a few demos and you just get to see the code.
Out of curiosity, how does it compare to Liquid Haskell? I'm more familiar with that approach.
So I'm more familiar with Haskell's like base language than I am with its extensions, especially like Agda and Liquid Haskell. I would say it tries to bundle a whole bunch of the dependent type features into this structure of refinement types and keep it a little bit enclosed, right? That you're going to do refinement types, but you're going to do them mainly by kind of designed by contracts, you know, a la Eiffel style things. And you're not going to end up in theorem prover mode. That's I'd say that's the big difference.
Yeah, that sounds similar to Liquid Haskell too. There's also this interesting language called Wiley. I'm not sure if someone has looked into that. That when you mentioned the preconditions, postconditions, that reminded me of Wiley. That seems to be.
You put links out for that before.
Yeah, sure.
I think I started it once or twice.
So the gist of it of refinement, let's say you have an int and you refine it that it has to be positive. It has to be greater than 0. Does that count for a refinement? Okay, but most of the refinements cannot be determined at compile time. That means they have to propagate to a runtime check. Correct?
Most of the refinement types in a language like F* can be satisfied at compile time, and it runs effectively a theorem prover in order to validate that.
Ouch.
The problem being that this is, in my opinion, I mean, I've experimented with these things in practice, and I don't think they scale very well.
I would be very upset with the compile time.
Yeah, so basically I think we need to figure out how to make some of these things bundle their complexity down to a point where we can corral it and then make it fast.
F* also call out to SMT solver to discharge those. That's also like, so one of the challenges is exactly the engineering the developer experience, as you mentioned, because if developers cannot count on their checking terminating in a predictable amount of time, that's not the greatest user experience.
Right.
That's
wait longer to see if my program compiles, or as I assume it's just
producing good error messages from failing to discharge theories that you are calling out to the SMT solver. It's still a bit of a challenge. There has been some work into that. We can break the clauses just right.
In the
so
example,
we can blame the failing clause, but it's not always easy.
So in the example, F* discharges its SMT solving to Z3, I believe. And how Z3 bring back information about what is unsatisfiable.
So I believe that it mostly provides a type error, but I don't remember so the things that are mostly unsatisfiable are like improper annotations. That is, the type checker doesn't complete or something like that. So there's It's a research
That's not
project,
good.
right? It's not a particularly interesting. I mean, that's like not a particularly interesting question to ask of a research project. The answer is badly, right? For any given error situation, the answer of how a research project handles it is like not well.
Yeah.
Okay, I agree that it's not the main focus. Okay, it's fine.
So yeah, so that's why I think it would be interesting. I don't think it's viable yet. So somebody needs to do a lot of work here.
I've been doing.
What would I pick in lieu of that if I had to build a production programming language now? I would build like a something system F based. Like I would probably get rid of subtyping. I just don't think it's worth it's
The full capabilities as system F. So there is kind of a distinction between the syntaxes of system F or the system F as a.
Yeah. So, some particular features that I would keep. Probably, would I keep rank n types? I don't know. Maybe. Probably. Would I keep?
The gist of it, basically the system F allows you to put quantifiers anywhere in the variable. That doesn't mean they don't stay top level always. That makes system F undecidable.
Yeah. So honestly, I would like to keep it all. I find it really useful to put various existential and universal quantifiers all over the place. Like I like that style of programming, but I also understand it's very difficult to understand. So I think that I would probably end up, after I do the first prototype and people yell at me, I'll probably end up with something closer to a conventional ML.
If you stick with rank n types, then that's what you get.
Yeah.
Quantifiers everywhere.
Right. Yeah. So I want it, and I would probably want to keep it, but I would probably get rid of it because people will get mad.
I personally like the reasoning. I'm much in line with your reasoning to why you should keep them. So
I think that the most interesting areas to innovate in are the pieces that we've seen a significant amount of movement in research and have yet to fold into a new language are probably innovations in module systems. I think the work on 1ML/mixML/ all of those where they unify the module system into a single construct. That seems neat. I love that. That's like an innovation of both the research and the practice side of like, can we fold all different module types, interfaces, classes, structs, whatever, into one thing, and then also make it type check and satisfiable in all ways.
That's what I'm doing with AA, or at least I think I'm matching up with what you're saying.
That's awesome. I love that. I feel like our preponderance of weird notions of modules is an artifact of our time, and there's probably a simple solution hiding way underneath.
I'm hoping that there is, because but
yeah,
I haven't got far enough along to say it's definitely going to work. But for me, it looks like I can just treat a module like a struct, and it has fields that all your module entries are going to come in. And
what is a module for you, Andrew? What do you think the concept module represents?
I very much align with the Rosberg Dreyer approach to modules, like that they're effectively, they want to feature the same things that you would in ML, SML in particular. So no subtyping, but varieties of structural members, as well as imports and exports.
So when you guys were saying modules, I was thinking namespaces.
Yeah.
So
that's
not
why
exactly
module is a different thing to different people.
That's pretty closely related to namespace. I mean, it's not, but it's close. There's a lot of
But some, for example, the SMO doesn't leak its internals in the module.
It's got
That's
various
true of
notions, right?
any
There's
namespace.
like, yeah, there's an abstraction boundary there. And the question is like, how much of an abstraction boundary do you present and like what kind?
Yeah.
Interfaces are a great example, right? They're like existential types. And SML is like, well, why don't I just write an existential type? Like I can do this using a more type theoretic approach to abstraction, as opposed to the like defining a new thing that is interfaces.
That was the signature. Maybe I
Yeah,
mixed them up.
but signatures are gone in MixML and in 1ML. They're just not necessary. The innovation was like, what if we just treat modules as having abstract imports? And then we don't need to actually have signatures. Like a signature is really just a module that only has a series of abstract imports, which must be satisfied by another module.
So this sounds like a constraint. The module has some constraints that has satisfied in the form of abstract types.
Wait, are you is this like considering, is this does this have the goal of replacing one module with another that has the same interface?
Yeah, like yes, the abstract data type versus concrete data type. Same idea, like that's one of the things that you do with modules. Namespacing is another, right? Like just literally putting things in names is another. Organization and data layout, like all of these things we kind of, it's a question of, are these different things that we should group into all of the different areas, or are they one thing?
I vaguely remember people having complaints about something like this because two libraries had the same interfaces, but they had different performance characteristics, and they had different defaults, and the defaults were just causing a lot of issues when people try to switch between them. So yeah, I kind of like knowing what the concrete is instead of like trying to write code for abstract.
I would hopefully think that the type system should be rich enough that you should be able to write against the abstract and have it behave as though you wrote against the concrete. That would be my...
That concerns eliminating that abstraction to a level that it's indistinguishable from handwritten code.
Yeah.
But it's like, let's say we're using OpenSSL versus one of the other SSL libraries. Different libraries will have different defaults on what kind of encryption or signature should be used or can be used as like not too old. So I heard people being bit by one supporting an older system and one not supporting it. Because I guess one company wanted old signatures and another didn't, and they had some kind of like vulnerability because of it. I don't remember the details, but yeah, it's, you can't really, I don't know if you can define that in the abstracts, but yeah.
So in theory, you know, if your type system is strong enough, you should be able to encode all these. In fact, I would say the research part of type theory is like, how can we encode all these things? So that's the general notion, like
that
given some arbitrary constraint, how could we encode it inside some signature?
Yeah, I kind of like that idea.
But you run into problems, like there's just a whole bunch of practical problems with all these things, right? Like ML's type system is actually very nice. It's not super rich. It's not all of system F, but it turns out in practice, it's got quite a lot of stuff, and you don't necessarily need a lot of stuff to do, let's call basic things. There was a quote from the creator of Scala,
Martin Odersky?
Yeah, Odersky, yeah. The principle of least power, use the least powerful language feature that you need to solve your problem. And I'm like a big believer in that.
I've kind of refined it. That's from Lee Hui, I believe, in his blog.
Oh, cool. I did not know that.
Yeah. I will share blog post.
Thank you.
In the docs, do you have the Google Docs open it? We have a docs that we document live.
Yeah. Oh yeah, you probably came in late. Yeah, it shows up in your invite. We add all these.
Oh yeah, that's great.
Yeah. people can come along next week when they're viewing it and go follow the links and stuff.
If people are following the use the least, I don't remember word you use, the least powerful. So in my language, I have a break statement or on break. I wonder if that would be the least powerful or if that would be if statements. Because to me, they're both if statements. It's just one's hidden, so it looks nicer.
Yeah, I think yours is a syntactic sugar for how to handle something. It's different from a typing system.
Yeah,
I would generally, I like to think of it as imagine two features, and let's say one can be expressed in another, but the feature that can be expressed in the other system can't express as much as the second. So it's like, you know, it's smaller in some way than the bigger feature.
then that would be my on break statements, and then I would agree with that. Yeah.
I would generally prefer the smaller feature, the one that can't do as much. The reason being that it's more constrained and has fewer options for what it can do. And therefore, as a programmer, as a reader of the code, I know that it's going to have fewer options in what it's going to do. And therefore, I can more easily understand the semantics because it's more constrained.
Yeah, I agree with that.
Sometimes you need, you know, first class continuations, but like 99% of the time, you really don't need first class continuations. It's my pitch.
Yes. Yeah. I have the theory or design criteria for AA that if you write C-like code, you get C-like performance. But if you do a upwards exposed fun arg and escape something and your continuation escapes, then you don't get C-like performance. You get all kinds of who knows what for performance. But hopefully the semantics are straightforward. Ugh.
Yeah, performance is like really complicated because it also seems to mix in an interesting way with the actual design and implementation of the system as a whole.
Yeah.
So I think of like a big difference between Java and the CLR, the JVM and the CLR in this way of like, if I read the JVM spec, it's written in a kind of like denotational style. Like, this is the thing that happens. It's not going to, I'm not going to tell you exactly what's going on. It's just like, here's the results, and that's what you need to know. Whereas the CLR and C# are tend to be more operational semantics. Like, I'm going to tell you the things that are going to happen, and that's what's that. Then the results are the result of that. And in some sense, this means that the way that C# programmers tend to get higher performance is they know the operational semantics of their things, and they change their code to match the operational semantics of the runtime. This has like both good and bad pieces to
That
it.
sounds
Like,
difficult.
Yeah,
it's hard for the programmer, but it means that in a lot of cases you can achieve things that you wouldn't necessarily be able to achieve otherwise if you didn't fully, deeply understand the implementation of the runtime. And also you can kind of be guaranteed that the runtime is going to cooperate with you in this endeavor.
Yeah.
Versus the other way where it's like the runtime just gets to make your code faster at any point. But on the other side, like, a developer is very rarely empowered to like make a particular performance optimization and be confident that it's actually going to result in a performance improvement.
I do that all the time, but I have an unfair advantage. I would love to be able to share how to do that with folks, and I don't know how to share that. The JVM's compiler, the JET, is a, you know, basically comes from a C compiler's head. So if you write C-like code in Java, you'll get C-like performance out of the JET. But like, somehow that doesn't translate well to sort of the next generation of Java programmers who never had a cost model kind of baked in their heads.
It's hard, and I don't have like a good solution for it. I feel like everybody's got their pick on the spectrum, right? Like, you can, one thing is that you can make it really common in your ecosystem. By publishing this kind of operational semantics view of the system, you can start to build a culture of like the internals are somewhat documented, and that people are just get to know like, oh, this is how it works, and it's not going to significantly change because, by the way, we published how it works. Like, you can't go back from that. And so it ties the hands of the implementers a bit, but then it gives the programmers a little bit more power, and you always go back and forth on this.
Okay, yeah, but the Hotspot's core internals implementation for performance hasn't changed in 15 years.
Right.
So there's some reasonable things you could come out and say now that are pretty freaking solid about what you can do and what you can expect when you do this.
100%. And a lot of it ends up being cultural. Like, is this a thing that's considered okay in your community, or is it like gauche to depend upon the compiler internals, that kind of thing?
Yeah.
So speaking of mental cost models, it still weirds me out that senior C++ developers still struggle with memory in C or C++, because
dude, just get your program ever more complicated until you can't handle it anymore. Everyone hits that line.
Yeah,
they all
but,
drive
like,
up to it.
I think in the 90s, there were people writing their own malloc, so it can tell them it reports memory leaks. And this sanitizers now, and most people, I think a lot of people use unit tests. So I figure with all of that, like your own malloc, unit test, a professional written leak sanitizer,
And
you'd be able to figure that out. But
so
people
I just
don't figure it out.
want to throw out here that, you know, the war stories for Hotspot, right? So back in late 90s, early 2000s, I'm hacking Hotspot furiously. Every race detector and every leak detector on the planet was attempted on the Hotspot source code base, and they, by and large, all internally crashed or failed to load. They didn't get even to square one. None of them got remotely close to being able to do anything. So, you know, whatever you want to say about, hey, leak detector, I'm throwing exceptions and catching them, and that's okay semantics, and I'm running with them, and I'm hacking memory, and I'm self-modifying code, and I'm jitting code on the fly, and then jumping to this byte of buffers I just threw the code into, and all these things caused all these guys to like barf and die. Maybe the situation's better now, probably is.
I think there's
some early 2000s, none of those tools work. Valgrind was 2 or 3 years of us going back and forth with Valgrind to get Valgrind to work at its enormous slowdown factor on Hotspot. You know, 10x slowdown. We got Valgrind work after like 2 or 3 years of hard work.
Yeah, that one is. I found it to be slow as well.
I think we are going to continue to see memory safety problems within the C++ projects where C++ is the hardest to use, and that's large legacy applications with huge shared mutable state. In other words, web browsers. And to Levi, I would recommend you an exercise to implement a web browser that correctly implements the document object model, and then check if you have memory safety errors. And then maintain it for a few decades. And then see if you still have no memory errors.
That's why I want these things in the type system. It's my opinion, of course.
I don't ever want to implement anything written by a committee. That's it. That's all.
Well, okay, fine. But there are a lot of cool things. All right. The web is possible because, not saying that I'd love to implement one either.
Yeah, I don't tend to implement operating systems for fun anymore, but so we had with the CLR, we do have ASAN running successfully. So it was a lot of work, but it paid off. There are terrible, horrible parts of the CLR that I don't want to tell you about, but like there's also a few places that I thought were interesting when we were doing runtime.
It was about the great parts of C# and CLR. What are you most proud of? Or thinks it's the most strong part?
Okay, so the interesting thing. So first, the interesting thing about this, the memory monitoring, runtime memory monitoring, was actually a number of places that were caught were races, like that. Okay, you're doing a data race here, but it was a deliberate data race. Like one of the things that you figure out about really high performance computing is you precisely understand the memory model, and then you race like hell so that you can get some real good performance.
There's a lot of those in Hotspot.
Right. like the core pieces of all of the runtime are like that. And so everything was being flagged, and we were just like, okay, I guess this isn't that useful. But
I never
yeah.
try to use race conditions like that. That sounds interesting, but it sounds difficult.
So
you just have to really understand your memory model.
Right. So two guys are running forward and they're executing code as fast as they can, and they run across an inline cache, which is I'm going to compare to see what my class and see if it's the expected one. So I'm going to compare my object's header class and jump not equal to fail and make an x86 call out to the correct guy. That's an inline cache. Okay, I just JITted one. It's not yet filled in. I don't want everybody who approaches an inline cache to stop and do some extra checks to see if it's filled in or not. So they all just run straight through. Well, not filled in, the call op and the jumper op are all hardwired to fail you now and go fill in. Somebody fails first. Several people may fail racily. They all do the same lookup. They all agree they know what the hell the inline cache should be. They're busy scribbling in the same exact bits. And then as they write them, next guy's running into it and it's got the correct bits now. So he just plows through. And everyone else thereafter just plows through. So that's the high performance model. The inline cache, when it's working, is 2 clocks at tops. And when it's broken empty, you need to repair it. And everyone races to get it done first. And then they go back and race right through it.
Yeah, at the fundamental level, it's like if you're guaranteed that the two people who are racing against a value are going to write the same thing at the end, then you don't care. Like, let them race. The first person who wins, great, that's fine. And then the other person overwrites it, also fine. Like, it doesn't matter. And you stop. You don't have the overhead of synchronization,
right,
which is high. So like,
which is high. Yeah, that's the trick. It's a lot of high sync. Yes, those things are high. There's a lot of those kinds of one-shot init things where you touch it for the first time and everyone agrees what they're going to write. But
and Andy, are you writing this code in C or C++?
The runtime is written in C++. So this is the terrible part of the compile.
Okay,
so the runtime is written in C++, but it is written in a very, very simple style of C++. It does not. Hotspot. It's even worse. So it doesn't use the standard library.
I've done that too.
The reason is
Hotspot. Yeah, fine.
That the C++ standard library can't be used because of the way the debugger works. So the way that the runtime and the debugger interoperate is the debugger and the runtime effectively both have a copy of the CLR inside them. And the difference is that when the debugger compiles, it basically sets a whole bunch of defines to create a slightly different behavior. And then when the debugger is executing against the code, it effectively models the CLR that's under debugging internally using the slightly different copy of the CLR that it compiled itself. And so it basically maps memory addresses appropriately and then reads data structures appropriately so that it can map between the thing that's being debugged and the debugger itself. And this whole process is like terrifying, but it works. Right. And it results in a knowledge of the data structures on both sides that is somewhat unable to go out of sync because they're compiled from the same source code, just in a slightly different mode. But this also means that you can't use things that like stash away pieces of the memory in places that you can't see it, like say the C++ standard library, because it compiles pointers differently, because the pointers don't refer to the code in my process. They refer to the code in the debuggee's process. So that's the key. You need to like proxy all of the memory to the debuggee.
That's interesting.
If I understood correctly, that mostly means you cannot use standard library containers, but there should be nothing preventing you from using standard library algorithms, right? Because these are just for loops wrapped as function calls.
In theory, yes. So
one exception that allocates on the side.
We also can't do anything that allocates, and we can't have any exceptions. So that does limit things. That said, there is nothing stopping us from going to the C++ standard library, finding the algorithm we really like and copy pasting it into our own source code and removing the bits that don't function properly, which is what we do every once in a while. It's not great, but it is what it is. And this is both a significant form of technical debt and also like it works well. And honestly, the alternatives are not fantastic. It's something that we're looking into, like, how do we want to evolve this design? But it has also successfully made it work for 20 years. So
nowadays that allocator story have gotten better. You could control all of the allocation done by the containers, including how it propagates through the container nested inside container by just controlling your own allocator. So for example, I know of the embedded real-time devices that are using C++ standard library this way. They can never allocate on the heap, not even 1 byte, because it's embedded. But they basically write their own allocator that uses the stack that has hard bound on, say, 1024 bytes. And this is going to be used for all of the standard library containers. And they have some form of guarantees that this is never going to be exceeded. So I guess you could adapt something like that. Not that it's necessarily trivial, but it's doable.
yeah,
No,
we're not so much worried about the allocation itself. It's more about the pointers going, it's about the creation of pointers that we can't track, right? Because we need to remap every pointer through a pound define into, or through a macro, right, into a different address space. And so that's
right. You would have to control the entire allocator story from the very beginning, not even using malloc. You could use your own replacement.
Yeah, we
Controls
do
which
use,
memory space.
in some cases, we do just use the standard system allocator because we know that things are going to be kosher, but like it's hard. Yeah, there are a variety of reasons why we'd like to change it. It's just that one has a lot of inertia behind it. And yeah, we do have somebody on the team who's on the C++ standardization committee. So that
No,
helps. Like he provides a lot of guidance.
I really like the idea of not using a standard and having all your code your own. Like it's been working for me very well. I had no issues. Because one of the things I noticed is a lot of projects, static analyzers struggle with the standard library, and the optimizer doesn't always generate the code that you expect. So if I'm writing everything, if I'm not using the standard library and I know certain things will optimize a certain way, it just and certain things are very simple for static analyzers to understand, you can get like a lot of good information out of that. Like I think it's a really good idea to not use a standard library.
I mean,
but I'm a
do
strange
miss
one.
Strings, like just strings.
Yeah, there's right. There's some things that I don't want to bother with. That's the reason for a standard library.
I implement my own strings. It was fine.
Well,
You have the option to use UTF-8 and guarantee it's always UTF-8.
Oh no, wait, sorry, we work on Windows. That's UTF-16.
You don't have that option. I was talking to Levi.
Yeah, you mean UTF, you mean WCHAR, right? Like,
Yep.
yeah, of course.
and hash tables, and in particular concurrent hash tables, and every
Oh my
other
God.
container thing on the planet.
We've got like 14 lock-free concurrent hash tables for every slight thing that you need. Yeah.
Why that many? Like, I don't disagree that you should have many hash tables, because I have two that, well, I had two that were on per thread, like they're not concurrent. But why 14 concurrent hash tables?
They all do slightly different things. They just have slightly different semantics. And it turns out if you have somebody who understands your memory model really, really well, and understands the problem domain really, really well, they can write a new lock-free concurrent hash table for exactly this thing that's 5% faster, and it's going to be 5% faster for like every 10 instructions. And you're like, okay, that matters.
Yeah, no, I agree with that. No, it sounds good.
I mean, it's not good. Like debugging these things is hell. And there's basically like, you end up in the situation where you end up with 2 people who can actually debug this thing.
Mhm.
And even then they're like staring at the code for days, trying to figure out what went wrong in this situation, because you don't have any kind of reliable telemetry or anything about why your hash table is suddenly going wrong. You just have somebody hands you a dump one day and is like, look, the runtime crashed, and you open it up, you're like, good Lord, what happened? All this stuff is gone. And then you just try and recreate the crime scene from the pieces that you have.
Yeah.
I remember Cliff having something with concurrent hash tables that was basically, I think he proved that it can't go wrong. I'll let Cliff speak.
I have a concurrent hash tables, not liking HashMap. I had some guy run through with one of the theorem provers and claim it was correct. It uses a state machine to describe the state of memory. It's actually been downloaded and used. I don't know. Now it's in the high hundreds of thousands of downloads. I got routinely proved as fast as general purpose hash table floating around, and it's also concurrent safe. But if you have specialized knowledge about your domain, you can obviously beat it. But if you're
That sounds like one problem where type systems could help and currently don't. Think of correctness of log-free data structures.
Yeah.
At the very best, you can throw a theorem prover at this if you can carefully encode the invariants that your data structure satisfies, but you are basically writing the specification again in another specialized language. But I don't think there is any language with a good story for correct log-free programming right now.
Oh, yeah. Okay, fair enough. I mean, I had a grad student volunteer for his, thesis. Go do that on non-blocking HashMap. That was fun. But I wrote in Java code, although I wrote the Java code from a carefully written state machine that I had in my hand, and it's documented in their slides and all kinds of stuff. But I took a state machine and I implemented it in Java. And then there were some wrappers around to deal with various things that had to be dealt with. But sort of the core of why I thought it was correct was because I was hand carrying state machine model into Java code. So now, did you have a state machine for concurrent programming that you could just write as a state machine and get performant concurrent code out? I don't know.
Yeah, and all of that sounds really viable, and like honestly would be a significant improvement on the status quo in a lot of cases, I feel like. But one of the kind of difficulties of this that I don't think gets addressed that often is that it often requires a union of 2 specific skill sets that are not too common. Like you might have somebody who's really, really good at writing lock-free hash tables and somebody who's good at writing like theorems and proofs. And those 2 people aren't the same people, and they may not work for you. So
the same people, yeah.
Yeah. So like that's the task that I run, or that's the problem I run into a lot, actually, that people just specialize. They get very good at particular skills, and then certain other things, that's not within the main skill set.
Not what you do. That's right.
Well, I never used any theorems, but I did kind of have the leak sanitizer help me out. Essentially, I had no problems implementing my threading in my compiler, but I thought that was embarrassingly parallel. So I know you don't need both skills because I managed to write my compiler without the theorem skill, but yeah, I think it's doable.
Your issue here, for me at least, is that you've picked a very simplistic language, which is fine. And you have a very straightforward, simple type system, which is fine, but that means that your type theory is extremely simple, which is also fine. And honestly, C has lived in that domain forever and a day. And Java's not hugely far. If you ignore generics, Java's not hugely far behind it. So that's a fine domain, but to say that you don't need types, I think you haven't tried.
Oh, no, that's not what I meant. I meant you don't need the skill of having a theorem prover to actually be able to do it without any bugs.
Yeah, most folks have not used the theorem prover.
The vast majority here, compiler engineers are not type theory people. That's one of the things that's true about
the trick here is to make the compiler to be your theorem prover or whatever prover.
You got
You
to
don't have
implement
to write the
compiler. So you're
and the
implementing a theorem prover.
Okay, but you have to implement it once, and the user don't have to
Oh,
understand
no, the
that.
users aren't. Oh, I always say that C2 is a giant theorem prover. And if you screw up or C2 screws up internally, he proves false is true, and then he deletes your program as part of, optimizing.
Okay, as part of its analysis, but it has a runtime data. That's what's theorem proving about dependent types about it. It's citing it's simulating the runtime somehow, but the C2 has the runtime in its hands. It knows about types and the most precise types at here and now. It doesn't need to prove anything. It just sees it.
Well, I'd say the theorems may be less complex, but it's still proven. The question is like how complex are the theorems that you're proving? C2 tends to be proving some rather simple theorems, but that's fine because it turns out proving like very simple things about your program can catch the vast majority of bugs.
Well, and performance for C2 is what the code you're generating. Hey,
same deal, right?
That this subtype stat, this is always at this class and that's always at that class. Therefore, I can make this a static inline call and inline the sucker and things like that.
Yeah, I go back to the like unreasonable effectiveness of ML, right? Like, oh, ML is just not a super complicated type system, but it turns out like most of the actual domain problems I run into can be satisfied by its pretty simple type system.
Yeah.
It sounds that we all need AI accelerators, and by AI, I obviously mean abstract interpretation.
Of course, of course.
Boy, if I could get something to help me write that is true. Okay, I write probably 90% of my like spare time code is some form of lattice flow analysis.
See, lattice theory.
See, you come to the right place.
You guys all need to learn your lattice theory here.
If
I'm a
I
big
could
fan
get
of lattice theory.
something to like super like speed up that process, that would be fantastic.
What do you use Lattice for? So obviously we are excited about Lattice here.
What don't use that Lattice for?
So in this case, I would like to add substructural typing to C# as an annotation. So C# the compiler, because it was built as a modular kind of, it was built as a compiler as a service. So you can query the compiler for all of the information that it has about your program. And that means that you can do things like we have analyzers in the C# compiler, which are just DLLs that it loads and then it executes against your code, and they can produce warnings.
I like them.
Yeah, it's honestly, it was a great feature. I mean, it was kind of like the simplest thing that we could think of that would be useful, and it turns out to be incredibly useful.
Yeah.
So I would like to build a system of attributes that you put on things like, okay, I'm going to mark this resource type as being affine. And then I would like for the fact that it is affine to be proved all the way through the state. And the way you do that is like, at minimum, you basically have a definite assignment like lattice analysis. And you say, okay, at every point at every flow control point in this method, when I leave the method, have I either transferred ownership of this type to somebody else, or have I called dispose? That's like the simplest version that I can think of. And I'm going to go build it. But the problem is that doing like a somewhat novel lattice analysis is expensive. It's not even that like conceptually expensive, but there's a lot of code and you have to deal with a lot of cases because I'm not writing it on the IL because I don't have the IL. This is like this is the C# code. So you have to like handle all that. Now on the plus side, you don't have to handle async or iterators, which are lowered away in IL and would be murderous to try and rehydrate after the fact. But you still have quite a lot of statements and expressions, and you have to know and handle all of the semantics of those statements and expressions and flow control operations.
I would rather put them into a lowered IR and handle it all there, but
that's one option, right? Like there is an internal, it's just not public. And so I could, yank the internals of the compiler out and then start maintaining my own fork of the C# compiler. And you never want to go down that path unless you really need to.
Fine. Yeah. All right, I'm rapidly approaching noon.
Yeah.
This has been very entertaining, and I'd love to come back and quiz you on lattice theory things, but fine.
I'm a simple man and I don't know a lattice.
But
No-
one of the first optimizations you'll learn in any compiled optimization class is constant propagation with a lattice. You'll get that if you ever go anywhere toward doing any optimizations. Step number one, do a lattice.
See, the thing is, like with register allocation, I knew it, but I didn't know I know it because I learned it with a different name. So I just had no idea. So I might actually know a lot about it. I just
Register
never
allocation
knew.
waits till later in your coursework because it's a hard problem and there are lots of interesting non-obvious choices in register
See,
allocation.
when I learned it, the guy told me it was called instruction scheduling.
You can
I
combine
know it's not the
instruction
same.
scheduling and register allocation, but those are not necessarily the same thing. All right.
Yeah.
Till next time. This has
Oh,
been a
it's-
fun
it was-
one. I'm very
Thank
happy to
you,
be-
Andy, for having me here. It was
Yeah,
interesting
and if
discussion.
anybody comes up with any clever solutions to supporting the C ABI on arbitrary platforms, let me know. That one bugs me.
I wouldn't mind
come-
talking about that next week.
Come excite people about that. And you'll probably get somebody wanting to do something about it. Next week, I may be on, well, it will be on Crete. I may or may not run Coffee Club. I will announce the day before, depends on my Wi-Fi and whether or not I'm jet lagged to hell and gone or not. It happens roughly at dinner time, so too much beer and I'm not necessarily suitable to moderate. Or maybe it's better, I don't know, maybe. So, but the week following, knock on plastic, I'll be back. So next week, it's a maybe. And it's been very fun, and I hope to see people again. Bye-bye.
Bye.
See y'all.